Today, you're going to be learning to graph absolute values. Absolute values, the parent function is f of x with the absolute value bars with x in the middle. Remember, the absolute value bars are the distance from 0. So if you're doing 0, it'd be 0. 1, 1, 2, 2, 3, 3. So in the calculator, if you're using your calculator, let me pull mine up. You will go to math, go over to number, and hit absolute value. And then we're going to plug in these numbers. -3, get an answer, 3. And you'll start seeing the pattern. It makes all your numbers positive. 3, 2, and 1. So 0, 0 is in the middle. 1. And I know I just chose those 5 points, but this bar goes, this V shape goes on forever in both directions. To the right and to the left, make sure you have arrows going. Try to hit your line. I missed mine. Okay. Domain are your X values. And you read those right to left. Oh my goodness, left to right. So I'll do this so you can see it. So if you're starting on the left and reading to the right, the first thing you see of your graph is that arrow headed left forever. Left forever is -infinity. So we'll have parentheses, -infinity, and then we'll keep going. We're talking about x values. I have x values all at these points and in between these points, and then the last thing I see is an arrow headed to the right forever. Right forever is positive infinity. So it's going to extend in both directions on the left and the right. And that's because I could plug any number I want in this equation and get an answer out. Unlike the range is your y values. And we still go from least to greatest, so from bottom to top. So starting at the bottom and going up, because we go least to greatest, and our negatives are a smaller number. I don't have any y value, no graph down here yet. No graph, no graph, no graph. Oh, here's my first graph right here. And the point here is 0. So there is a point at 0, so bracket 0, because it's included. I can plug 0 in and get out 0. And then we keep going. I still have y values. There's 1, there's 2, there's 3, there's 4, there's 5, and then there's arrows going up forever. Up forever is also positive infinity. So if you're talking about the domain and your graph is going to the left forever, it's negative infinity. If you're talking about domain, it's going right forever, positive infinity. If you're talking about the range, down would be negative infinity and up would be positive infinity. So since these arrows are going up, positive infinity. So the graph looks like a V, and the turning point is called your vertex. And that's one of the most important parts of this graph. At any point, if you need to stop this video, please feel free. I should probably get there. Your transformation equation, there's 1, 2, 3 different parts of it. So if you're looking at A, I'm going to do A in blue. So a number in front of your absolute value bars. If it is negative A, it's going to be a reflection over the x-axis. Which will make the V go down. If it's bigger than 1, it's going to be a vertical stretch. And think about when you do a vertical stretch, like pulling silly putty, it gets thinner. If it's between 0 and 1, your fractions, your decimals, it's going to be a vertical compression. And when you compress something, you squish it. so it's going to get fatter. So that's what all the things A does in this equation, the number in front of your absolute value bars. Inside is opposite of what you see. So if you see a plus H, that means you had to plug in a negative because two negatives make a positive, and that's going to be left. So if you see a plus, it's actually going to go to the left because two negatives make a positive. Negative H is actually going to go to the right, because I would have plugged in a positive even though because the equation's negative. And lastly, K added to the end. This is very easy. If it's positive K, then it's going to take your graph up however many points. And if it's negative K, it's going to take your graph down however many points. The biggest thing to know, the biggest key feature is your vertex. And from your transformation equation, it is HK. That is your vertex. And remember, H is going to be opposite of what you see. So if you see, and I'll show you some examples. To create a table of value, it is best to pick the vertex in the middle and then values on both sides. Find the x value of the vertex by setting the expression from the inside the absolute value bars equal to 0 and solving. So if you're trying to find the vertex, it's when the inside of your absolute value bars is equal to 0. So if I set x minus 4 equal to 0, and I add 4 to both sides, then x equals 4. That is my vertex. And as the directions say, put it in the middle. So 1, 2, 3, 4, 5, 6, 7. In the middle would be here. So this is going to be my vertex. Transformation equation. F of x is a parentheses x minus h plus k. Remember, h moves it right and left. So since you see a negative, that means it's going to go, your graph is going to move right 4. So even though you see the negative 4, right 4, negative to the right. And if you forget, come up here, negative to the right. So that's why it is now at plus 4, and then we're going to plug in numbers 3 smaller and 3 bigger. So this will be 3, 2, and 1, and 5, 6, 7. And then we just plug them in. So you can use the calculator. I'll use it for the first few, and then sometimes it's just easier to copy it down. So I'm plugging in 4 minus, I start with the vertex. So I'm plugging in 4 minus 4. That's 0. 4 minus 4 is 0. The absolute value of 0 is 0. Now when we get to 5, 5 minus 4 is 1. And absolute value of 1 is 1. If you do 3, I know I'm not going in any specific order to you yet, but you'll see why. If I plug in 3, 3 minus 4 is negative 1, and the absolute value of negative 1 is positive 1. See, so I'm at 4, 0, 1, 5, 1, 3, negative 1. And I'm going to let you know, A is the slope to the right of your vertex. A is the slope to the right of the vertex. So what that means is, right now my A is 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. And if you plug them in, 6 minus 4 is 2. The absolute value of 2 is 2. And the same thing here. 2 minus 4 is negative 2. I'm going to write this down. 2 minus 4 is negative 2. And the absolute value of negative 2 is positive 2. So you can hopefully see the pattern. So after you use the slope to the right, up 1, right 1, up 1, right 1, up 1, right 1, you're going to reverse it to the left. Up 1, left 1. So that you can create your V. You can use your points to plug it in if you're having trouble. Oh my goodness. There we go. Try your best. Use your ID, connect your points. something like that. Okay. So our vertex, I got 4. When I plugged 4 in, I get 0. So our vertex is a 0.40. Our transformation is right 4, which makes sense because if your vertex of the original is 0, 0, and our graph moved right 4, 1, 2, 3, 4, now it's at 4, 0. So that's this graph. So what that changed, the domain still to the left forever. We're talking x values, left forever, right forever. Domain's not changing. And range, be careful, it's not 4 because this point is 4, 0, and range is y values. So y values is 0 to infinity. So that did not change. Even though my graph shifted to the right, it did not change. So bracket 0 to infinity. We'll speed this up. You can always speed this video up too if this is making sense. But we have 4 more. Or you can slow it down if I'm talking too fast. So the original equation, y equals a, parentheses x minus h. This one doesn't have an h, obviously, plus k. Our a is 1, right? It's not moving. We don't have an h. And our k is 5. K is 5 plus 5 plus 5 means your graph is going to go up 5. So if your original vertex was 0, 0 here, and I move it up 5, 1, 2, 3, 4, 5, now I'm here. So my new vertex is 0, set the middle equal to 0, x equals 0, plug it in, and get 5. 0, 5. Put that in the middle of your chart. Go down. Come on. And count up. You can use your equation and plug it in. So, like I was saying, you can plug in your numbers, 1 plus 5, absolute value of 1 is 1, plus 5 is 6. And it is symmetric to the vertex, so this will also be 6, 7, or 8, and 8. So 1, 6, 1, 6, 1, 7, 1, 8. Or again, the slope is 1, up 1, right 1, up 1, right 1, up 1, right 1. And then to the left. And you also have those numbers. Okay? This arrow is going left forever. Be careful. Left, not up. Up is range. Left forever, negative infinity. And this arrow is going right forever, positive infinity. Hopefully you're seeing the pattern in the domain. Left forever, right forever. But the range changed because range is y values. And if your graph moves up 5, then when I start looking at y values, start at the bottom, work your way up, no graph, no graph, no graph, no graph, until I get to 5. So my range also moved up 5, and it's going up forever. Okay, now we're going to do 2 transformations, and a has changed. So a is my number in front of my absolute value. It is 1/2. 1/2 is a in between 0 and 1, so that is a vertical compression. So vertical compression by 1/2. And think of like stepping on an orange, it's going to get fatter. And then -4, so that will also be down 4. From the directions, if you set the inside of your absolute value equal to 0, so inside my absolute value is just x. If you set that equal to 0, that will give you the x of your vertex. To find the y of your vertex, you plug it in. The absolute value of 0 is 0 times 1/2 is 0 minus 4 is -4. So what that moved, it moved it down 4. It was at 0, 0, and now it moved down 4. So my vertex goes in the middle, 0, -4. And now this is a little different. I want values going down and values going up. And I'm going to take half of those values. So you get to choose these numbers. I'm not saying they have to be the very next ones. Since this is, I'm going to take half of it, I'm going to use even numbers because I know half of 2. I know half of 1 is 0.5, but I don't want to graph decimals. So I'm choosing to use even numbers, 2, 4, and 6, right? And so -2, -4, and -6. So whatever you decide, if you decide to count by 2s, make sure you do it in both directions. You don't have to. Again, you can use 1, and if you plug in 1, you're going to get a decimal, and that's just annoying. But you're more than welcome to do that. You can plug in whatever numbers you want. You can, if you get stuck, you can plug in -8 all the way to +8 and graph this. So 1/2, hopefully you just put in 0.5. That's a lot faster. 1/2. I'm going to check my vertex, make sure I did it okay. Math over to number, absolute value. I did 0. I know this, but just in case you're worried, you can always check your numbers. -4. Now, like I said, you can plug in 1. You can plug in any number from -8 to 8 for your x, and you'll be able to get the graph. It'll take you a while. And you'll get fractions, which you will then convert into decimals. But why do that when you get to choose these numbers and you can choose nice numbers to graph, like -3? And when the equation gets complicated with vertex, I really do suggest plugging it into your with vertical compressions, I do suggest plugging it into your calculator. And 4 is -2. I'm gonna do all of them real fast. I plugged in 6 and got -1. I plugged in -2 and got -3. I plugged in 6 and got -1. I plugged in -2 and got -3, because this is your vertex. This is my vertex. So you hopefully can see the pattern, -2, -1. All right, to graph these points, remember A is your slope. So if you have your vertex graphed to the right, you're using your slope. Up 1, right 2. 2, -3. There it is, 2, -3. Up 1, right 2. Up 1, right 2. 4, -2. So there are your points. And then to up 1, left 2. Up 1, left 2 to complete your pattern of your V shape. And you can check your points on your calculator. Now, like I said, if you did choose to use 1, that is fine. I plugged in 1 and got -3.5. 1, -3, 1, 2, 3.5. That's this point. That's fine. You can do that. See, it's already there. Domain, always -infinity to +infinity. And then range, start at the bottom, work your way up. Nothing, 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 nothing. And here it starts, -4. Included, -4, 2, and then up forever, +infinity. Okay, last 2, and then you can go do your summit. Okay, a negative in front, that's your A. A is -1. So that is a reflection over the x-axis. And then +1, remember if you see a positive inside, it's doing the opposite of what you think. So positive would mean left 1. Most people think positive right. Inside the absolute value, they're lying to you. It's doing the opposite, so left 1. To get your vertex, you're setting the middle equal to 0, or it was at 0 and you moved it left 1. A lot of different ways to do this. So it's going to be at -1. So my middle graph, this is my vertex, -1. That bothers me. And then you can plug it in. -1 plus 1 is 0, and the absolute value of 0 is 0 times -1, because that's what this is, -1's doing. It's going to multiply everything by -1. It's still 0 though. So I was at 0, 0, and then I moved left 1. So now there's my vertex. Now we want points to the left and points to the right. So -1, 0, 1, 2, -1, -2, -3, -4. If you plug in 0, you get 0 plus 1 is 1. The absolute value of 1 is 1 times -1 is -1. So plug in 1, 1 plus 1 is 2. The absolute value of 2 is positive 2 times negative 1 is negative 2. And then negative 3 as well. Plug it in. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1 times negative 1 is negative 1. Or put it in your calculator. I'll put 1 in your calculator just so you can see it. Get to the bottom. So negative absolute value. For x, I'm plugging in, I'm going to do negative 3 plus 1, negative 2. And hopefully you see the pattern. Negative 1, negative 2, negative 3. Negative 1, negative 2, negative 3. Or again, A is your slope. So from your vertex to the right, slope to the right, I'm going down 1, right 1. Negative 1, down 1, right 1. Down 1, right 1. And there are the 3 points I just graphed. 0, negative 1, 1, negative 2, 2, negative 3. And then to the left as well. Worst case scenario, you have absolutely no idea how to graph this on the test. You can sit there and plug in negative 1, negative 8, negative 7, negative 6, negative 5, and you'll start getting points and graph all of them. Domain and range, negative infinity to infinity. Domain is your x values. Range is your y values. For x values, they're going left forever, that's negative infinity. They're going right forever, that's positive infinity. Range, those are my y values. Start at the bottom and go up. Be careful though. Even though there's nothing down here, that's because I didn't graph it all the way down. These arrows are going down forever. So they should fill up your whole graph. Or have arrows and know they're going down forever. For y values, going down is negative infinity. If it was going up, it's positive infinity. So negative infinity to, where do my y values end? Here. My y values end at the vertex. Negative 1, 0. Make sure you use the y value of 0. Some people get confused because they see a negative 1, but that's x. We want the y value at 0. All right, last one, and then go practice. Transformations, there's 3 of them this time. A is bigger than 1, so that's a vertical stretch by 3. Negative 2 inside, that's my h. That means if you see a negative, that means it's going to be right 2. Positive 1 on the outside, that's my k, up 1. This is the original parent graph. This is not the graph we are actually graphing. So don't copy this. I'm just trying to show you. So if this is our graph, and we're moving it right 2, 1, 2, and up 1, it's going to be here, and then it's going to be a vertical stretch. I don't think I can actually stretch this graph. Right 2, up 1, and then it's going to vertically stretch it. Like think of pulling gum. It's going to pull it up and make it tiny. Okay, so let's do that for real. But hopefully you get the picture of what it should look like before you're even graphing it. If you set the inside of the absolute value equal to 0, add over your 2, your vertex is going to be at 2 because it was moved right 2. So 2, and then you can plug 2 into your equation to get your y. And when you have that many rules going on, I would plug it in. What's the harm? 3, 2, minus 2, plus 1. Hopefully you already know where it is from my little quick sketch. Positive 1. That's because it was moved up 1. All right, we want bigger numbers going down, smaller numbers going up. We have a slope of 3. That's very complicated. You're more than welcome to plug it in. You can even graph it and then look at your table. But I already have it here, so I'm going to plug in 3. 3 minus 2 is 1. 1 times 3 is 3, plus 1 is 4. So I'm at 2, 1. That's my vertex. And then my next point is 3, 4. Notice the slope, up 1, 2, 3 over 1, up 1, 2, 3 over 1. I'm guessing my next point will be 4, 7. It's already plugged in. All I have to do is copy it down and plug in a 4. 4, 7, there it is. And then you're more than welcome to plug in 5. You can plug in any number you want. It would make no sense to plug in anything smaller than -8 or higher than +8, but 10. And that's off my graph. So that's way up here. I don't care. And then the vertex, if I plug in 1, you will get 4, 7, and 10. Do your slope the other way. Make your V shape. See how it's getting thinner? That's what a vertical stretch does. You're stretching it out. Think of a rubber band, stretching that rubber band thinner. Domain, guess what? -infinity to +infinity, always for absolute values. Now range is different. Nothing, 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 nothing. Here's my first y value at 1. Then we have more y values over and over and over and over and over again. There's the graph. And then I get to an arrow going up forever. +infinity. All right. If you have any, oh, I forgot to fill out this part. That's it. If you have any questions, ask your teacher. Have a great day.